Hello, everyone. I hope everyone's having a good day today. I'd like to warmly welcome you to today's webinar on migrating to BricsCAD. Easily port your LISP scripts. It's fantastic to see so many of you joining us for this session. We understand that you might be thinking, migrating your cherished LISP programs can seem like a very daunting task. But we hope that after today, you'll see that it is possible and there's no need to fear. Think of today as more than just a presentation. It's an opportunity to unlock new possibilities, enhance your workflow, and elevate your CAD experience. My name is Claire Florentino, and I'm the Pre-Sales Manager for APAC and Bricsys. With me is Aman Jain, Bricsys Solution Consultant, who will be introducing BricsCAD today. We are also joined by Mr. Munish Bansal, Managing Consultant at Design Solutions Inc., and a well-respected professional in the industry. He'll be sharing more about his firm later on, but just to give you an idea, Design Solutions Inc. is a consulting company specializing in hydraulic design of pipe networks for water supply, irrigation, and sewerage, among others. And we'll be seeing some of the truly amazing things they've done with LISP in CAD. I clearly remember a conversation I had with Mr. Bansal. He mentioned that with BricsCAD being so cost-effective, he was initially expecting to make a lot of compromises. However, he was very happy to find that BricsCAD can do what he needed it to without compromise. More specifically, ensuring that they can continue to use their longtime LISP routines with no issue. They successfully ported over 100K plus lines of script, immediately proving BricsCAD is a good investment. Design Solutions Inc. is a valued customer of BricsCAD, and we appreciate their enthusiasm in sharing their wonderful experience with us. So for today, Aman will start with a brief introduction of Bricsys and BricsCAD and why it's gaining traction in the CAD industry, including interesting licensing options in BricsCAD that are no longer offered by some other CAD providers. He'll share a bit about LISP in BricsCAD and touch on Blade, BricsCAD's built-in LISP editor should you need it. Then we'll get to today's highlight where Mr. Munish Bansal from Design Solutions Inc. will share their experience on migrating more than 120 company essential LISPs from AutoCAD to BricsCAD, including why they chose to do so. Design Solutions has done amazing things with LISP, enabling their team to become more efficient as they automate many manual parts of their work. He will conduct a live demonstration to showcase BricsCAD and LISP in action. Some of what we'll see today are how Design Solutions Inc. uses LISP to automatically identify and assign node numbering and extract pipe data to CSV and Excel files. From there, they have created a bidirectional auto-location of pipe entities between BricsCAD and Excel, and are also able to auto-update data such as pipe diameters. The Design Solutions team also uses LISP scripts to automatically change pipe colors based on pipe diameter for better drafting visualization. We'll also see their enhanced documentation workflow using LISP, more specifically automating annotations to reflect pipeline diameter and length, junction labels, elevation, and pressure information. They've also successfully ported LISP routines to automatically create section profiles and spot elevations from contours, and calculate interpolated levels, helping to supercharge their process when dealing with water supply, irrigation, and sewage network design. Design Solutions has gone even further by creating LISP scripts for automatically generating sewer L sections and plans, and even key plans, complete with diameter labels, material, chainage, invert levels, truly amazing for productivity. They're also able to create required KML outputs to reflect their pipe network design on Google Earth. So I hope that got you very excited. These are just some of what we'll see where Mr. Munish will walk us through their workflow. He has a lot more in store for us. Finally, we'll wrap up with some LISP migration tips, BricsCAD's value proposition, and some time for Q&A. Feel free to ask your questions in the chat box. I'll hand it over to Aman now to start us off.
Introducing Bricsys. Bricsys is part of Hexagon AB, a large global technology group which had revenues in 2021 of 4.35 billion euros. So we have a solid foundation, and you can be certain will remain strong and dependable in the future. We have a huge customer base in over 110 countries throughout the world. We were established 22 years ago in Ghent, Belgium, which remains our global headquarters. We have a total of 8 offices throughout the world with over 300 employees, and we are supported by an extensive network of specialist partners and resellers. We therefore can offer a local personalized service, but with the backing of a huge multi-billion euro group. Our product family can be separated into two distinct categories: 2D and 3D design, construction and fabrication solutions, and a cloud collaboration solution. BricsCAD, our flagship offering, consists of two license levels, Pro and Lite, is a 2D and 3D general CAD platform that is often adopted to replace your legacy CAD systems. It provides a lower total cost of ownership with more innovative productivity than those other products. It has a proven track record in the building design and construction, civil as well as manufacturing industries. BricsCAD BIM is the intelligent building modeling solution that is based on the BricsCAD platform. It is fundamentally different from other BIM systems and is most commonly adopted by small to medium architecture and engineering firms moving from a 2D to a 3D work process. BricsCAD Mechanical is a solution designed for manufacturers, allowing them to develop product assemblies quickly and effectively. It is unique in its position, providing the optimum 2D and 3D mechanical design solution without the unnecessary cost and complexity of traditional CAD products. It offers the perfect feature set for many manufacturers at the very right price, making true mechanical design far more accessible for small to medium organizations. And BricsCAD Ultimate brings together all the functions of BricsCAD Pro, BIM, and Mechanical in one single DWG-based environment. This means it's uniquely placed to offer the perfect single design solution for those who needs span the manufacturing and building worlds, such as building product manufacturers. On the other side of our product portfolio, we have Bricsys 247, which is our cloud collaboration solution for pre-construction planning and execution. It is a simple yet powerful solution designed to connect all project stakeholders through document management, project management, and a common data environment. Let's talk about the licensing options of BricsCAD and its products. We offer our BricsCAD products with completely flexible licensing options. There is a choice of single, volume, or network, and these can be perpetual or subscription based. Licenses are linked to the organizations, not each user. So the restrictions and high cost imposed by named user licensing are eliminated. And the licenses can be used anywhere across the world. So for the perpetual option, you own your software, and yes, it's forever. And you have the choice of low cost maintenance to ensure you keep up to date with the latest innovative functionality as and when it's released. The subscription option allows you to rent your software, perfect if you want to optimize short-term project costs. And the ability for your licenses to float across a network offers a cost-effective option for those within the company who are not full-time CAD users. With Bricsys 24/7, of course, as it's a cloud-based solution, we offer a subscription model, scalable depending on how much data you'd want to manage. Let us have an overview of LISP and BricsCAD and move to our core topic for today's discussion. LISP is one of the earliest programming languages developed in the late 1950s to assist artificial intelligence research. Its name is short for list processing, and it was designed to handle list of words, numbers, and symbols. It is one of the most powerful programming language that's integrated into BricsCAD along with others like VBA, .NET, etc., allowing users to automate tasks, customize commands, and extend the functionality of the BricsCAD software. BricsCAD provides an IDE called Blade, that is BricsCAD LISP Advanced Development Environment, to help users to quickly write, execute, and debug your LISP programs. Whether it's automating drawing routines, generating custom reports, or creating specialized toolsets, LISP provides users with the capability to tailor BricsCAD to their specific needs. Now, with that being said, BricsCAD's implementation of Lisp is highly compatible with AutoLisp, the dialect of Lisp used in AutoCAD, making it easy for users to transition their existing Lisp scripts to BricsCAD. Additionally, BricsCAD offers a modern development environment, that is Blade, for Lisp programming with features such as syntax highlighting, code completion, and debugging tools to streamline the development process. BricsCAD's Lisp functionality isn't confined solely to its core platform. It seamlessly integrates with its specialized 3D modules like Mechanical and BIM. This means that users can leverage the power of Lisp not only for 2D drafting tasks but also for advanced 3D modeling, mechanical design, and building information modeling, that is BIM. Lisp in BricsCAD offers faster execution and improved stability compared to other CAD platforms. Thanks to BricsCAD's optimized Lisp engine, users can experience quicker execution times for their custom scripts and routines. To support my claims that I just mentioned, I will now hand it over to Mr. Munish to share his experience with BricsCAD and how he and his firm were able to migrate their Lisp routines from AutoCAD to BricsCAD. Over to you, Mr. Munish.
Thank you, Aman, for the warm introduction. It gives me immense pleasure to be part of this webinar. To start with, let me first begin by introducing my firm, Design Solutions Inc. Design Solutions Inc. specializes in project management, project consultancy, public health, and structural engineering services. With over 30 years of combined experience, our talented team offers comprehensive engineering solutions for various projects, including hydraulic design of water supply, sewerage, storm drainage, and irrigation pipe networks, surge water hammer analysis, design of water, sewage, and effluent treatment plants, etc. Established in 2006, we are listed in Trade India's list of verified companies, and we are recognized for our quality services to the market since then. Now let's talk about the reason why we made the switch to BricsCAD. First and foremost, BricsCAD's industry standard .dwg platform was a game changer for us. It was seamlessly compatible with our existing CAD files and workflows and made the transition smooth and effortless. We didn't have to worry about file conversion or compatibility issues, allowing us to focus on our projects without any interruption. We over 100K plus lines of Lisp code developed on AutoCAD. We initially thought that switching to a different CAD platform would be a tough challenge. However, BricsCAD proved us wrong. Not only were we able to migrate the entire routines seamlessly, but we were also experienced enhanced stability and even better performance. One of the most significant advantages we found with BricsCAD was its great performance, especially when handling large files. We work on a variety of projects that includes files of large sizes, and BricsCAD's performance capabilities have significantly improved our efficiency and productivity. We no longer experience lag or slowdown even with our most complex designs. BricsCAD's modern CAD tools with AI-based features have also helped us in a lot of ways. It's the first time that we have seen a CAD product offer so much more in addition to the regularly used features and functions. Commands like blockify, copy, move, guide, undo per entity, and many more are extensively used by our team and they surely love it. Moreover, BricsCAD's Licensing options, including perpetual licenses, offer us the flexibility and cost effectiveness we need to stay competitive in the industry. We appreciate the transparency and simplicity of BricsCAD's licensing model, which allows us to scale our licensing as our business grows. In summary, our switch to BricsCAD has been a game changer for design solutions. The clean migration process, better performance, modern CAD tools, and flexible licensing options have helped us to take our designs to the next level. Yes, so now let's see live demo of how we are able to implement this within BricsCAD. So let me open a new BricsCAD file. As I had mentioned earlier that we are in the design of water supply, sewerage and irrigation pipe networks. So when any new projects come to us, so we get a survey drawing in which the various roads are shown and the levels are shown, the streets are shown, the houses are shown where we have to design the water supply or the sewerage network. And once we get the survey, we draw the pipelines. We draw the pipelines on the survey plan as you can see here, like this is a sewerage network, and the arrows are the basically the direction of flow of the sewer pipe network that we have marked on the in the CAD drawing. So once we have marked this, then we have to take this pipelines to water gems or sewer gems or maybe any other software for design, hydraulic design. So, but before taking, we have to ensure that whenever there are two or more than two pipes meeting at a junction at a point, so this pipeline should be broken and also the branch pipe should also be at the same point. So, and in this point, three polylines are meeting and all the three polylines should have a same point. So there should not be that any polyline is protruding outwards or remaining away from the junction. So these kind of drafting mistakes should not be there. However, it is not possible manually for any draftsman to be 100% accurate. So we have built in a program, LISP program, wherein we can identify not only identify these drafting mistakes, but we can also correct them. So I will show you. I will do lay ISO. I will isolate the my sewerage network layer. Also, I will show you the blade environment where we do all the programming and everything. This blade environment is very good in debugging and in programming and testing your programs. So like we have made a program called ds underscore network check. As you can see, all this programming has been done by us in-house in our company. And all these functionalities or all these commands are all list commands, which we have actually implemented earlier in AutoCAD, but now once we have shifted to BricsCAD, so there we did not need to do any changes in these commands. So this entire program we are able to run as it is. So I will just show you live how this we are able to check the network done by the drafting people. ds underscore network check, and that's all. So basically it has identified various errors as you can see here. So this is a main pipeline and this is a branch pipeline which is meeting here, and this main pipeline should have broken here. So in this main pipeline, uh, there should have been a different, like this polyline should have been a different polyline and this polyline should have been a different. So it needs to be broken here. So one way of doing is it that we do it, give the break manually at that point. Another is that we have made another command called ds underscore correct. So when we run ds underscore correct, we have to select the polylines and automatically it will break at the required point, as you can see. And this functionality works very seamlessly within BricsCAD. Now another is the join error. See, this is a join error, error join. So here what has happened is not only is the main pipeline broken at this point, even the branch pipeline is not up to the required length. So it is remaining backwards. So again, ds underscore correct. So now the main pipeline has also broken as well as the branch pipeline has also been joined up to the main point. So all these points, like here, what has happened is branch pipeline is protruding outwards from the main pipeline, and the main pipeline also is not broken. So again, ds underscore correct. So now the extra length has been trimmed off and the main pipeline has been broken. So this is basically the functionality ds underscore correct and ds underscore network check. So now our network is finalized and now we are going to make nodes. So we will isolate the pipeline layers and then we are going to run the command ts underscore make nodes. So now, as you can see, this program has given a unique node number at every junction. Wherever two or more than two pipes are meeting, the unique node number has been given by the program. So now we can denote any pipeline by two nodes. Like this pipeline is from 344 up to 343. So each pipeline can be now named between any two given nodes. Now we have to take this pipe data to Excel. So there is another command ds underscore make pipe data with nodes. As you can see in the current folder, it has created two files, CSV files. One is the pipe file, so pipe data, wherein it has given us the from node, from XYZ, to node XYZ, length, whether it is a polyline or a line or SP line, layer name, and then quarter points and many other details. So we can use these details from Excel in any software or maybe manual Excel design also. So from to length, which normally people make manually, so it has automatically been generated through LISP. Now we are going to close this file and we are going to see how we are able to solve the network in Excel and BricsCAD. So we have linked Excel with BricsCAD and we are able to do data transfer both ways from Excel to BricsCAD as well as from BricsCAD to Excel. So this is a template wherein we are able to solve any water supply network. So once the data from to length is made and we give various diameters to the various pipelines for any water supply network, I will also open the corresponding water supply BricsCAD file. So as you can see, so this is my water supply network file wherein all these pipes and these are the various nodes and these the same data and the same files are now in Excel as well. So we are able to communicate between Excel and BricsCAD both ways. For example, if I want to see this pipeline from 8 to 125 with a length of 102 meters and diameter of 67.3. So I have to just select this pipe in Excel and press go to selected. So it will highlight the same corresponding pipe within BricsCAD. So as you can see, this data transfer happened from Excel to BricsCAD. Similarly, I want to locate any particular pipe from BricsCAD into Excel. So I have a command called locate in Excel. Let me run the command again, locate in Excel. I will select this pipe 43 to 86. And now this pipeline 43 to 86 has been selected. So as you can see, the data transfer has happened from BricsCAD to Excel. I will try with another pipe. Let us say I will go to 80 to 40. So locate in Excel, select this pipe. So now it has gone, the cursor has gone to 80 to 40. So it is very easy to shift between Excel and AutoCAD. Also, one more thing I want to show, another functionality which we have implemented in LISP is that once I am designing my pipelines, so these are my diameters, these are internal diameters of HDPE pipes. I can change the colors to diameter wise and also write the diameter 75 mm dia 6 kg pressure at the center of every pipe. So graphically, I can see whether all my, how my pipelines have been designed, and I can also I am having a better view that graphically that how my network will appear. Also, one more functionality we have done is that I can also change any diameter graphically and update in Excel. So, for example, this pipeline is a 75 mm dia pipeline. I want to change the dia to 90 mm. So I can do match dia. So I will select the source pipe, which is 90, select destination pipe 75, enter. So this pipeline has changed to 90, but this change has happened only in BricsCAD. So I need to update to Excel. So water supply export diameters to Excel. So as you can see, it has said one diameter updated. So one diameter has been updated, and we can also go to this particular pipe and see whether 33 to 34, the diameter has been updated. Yes. So 80.9 is the internal diameter of 90 mm dia pipe. And then I can maybe solve the network. So any change which I can do in BricsCAD, automatically I can export to Excel. Similarly, any change like 67.3, 41 to 4. So let us say I go to this pipe. This pipe currently is 75 mm dia pipe, whose internal diameter is 67.3. Let me change this diameter to 80.9, whose diameter is 90 mm. Now I will solve this. I will export this diameter to BricsCAD, and you can see automatically the diameter has changed from 75 to 90. So we are so very conveniently we can switch over from BricsCAD to Excel and Excel to BricsCAD. So any large network wherein there are thousands of pipelines, So we are able to switch over and see what all is happening graphically, as well as we are able to see what all is having, what all calculations are being done in Excel. So after our design has been done, so next functionality is the drawing generation. So right now what people do is that they generate the DXF file from any software like WaterGems or SewerGems, and then there is a lot of text overlapping, and then they correct the text overlapping manually. Like we have to write the pipeline diameter and length at every pipe, and also at the junction we have to write junction label, the elevation as well as the pressure. So we have developed a list functionality wherein the placement of text is automatic, so that there is little or very minimal overlapping which the draftsman needs to correct manually. Otherwise, almost 99% there is no text overlapping. As you can see, for the junction J155, the details are written on the north of the junction, whereas for junction 280, it is written on the right side of the junction, and for some other junction, it can be on the south of the junction, depending upon where the placement is being made possible, like that. So you can see the placement automatically. This is completely no overlapping of text is there. So I will generate. I will show you how we are able to generate. So we are having a list. I will drag and drop water generate drawing. All my final design data is in this Excel file, which is in a standard format. I will open this Excel file. The program will automatically open and close this Excel file, and I will mention the text size. I will mention the some functionalities which the program is asking. You can see automatically it is generating the pipeline and the junction details. So let us wait for some time. It will write the pipeline diameter and length at every pipe, and also for every junction it will write the junction label, the ground elevation as well as the pressure, and automatically without any overlapping. So wherever it finds any overlapping, it changes the location of the text. So as you can see, it has written the diameter and length at every pipe. There is no overlapping, and also it has written the junction number, the elevation as well as the pressure at every junction. So it is a beautifully made drawing. So water supply drawing has been generated. Similarly, we can generate the sewer drawing as well. So now we are going to see another functionality called ds underscore add block. So in our projects, we have to prepare a lot of piping and valves and fittings like vents, tees, reducers. So what we have done is we have created standard blocks for all these fittings, and our draftsmen or our drafting people, they just need to run a command called ds underscore add block, and this window pops up. So now lot of this window is all customized, made within BricsCAD in the list programming of BricsCAD, and you can see there is a lot of options here. So let me add a bend here, bend normal. Okay, so let us say socket, let us say ductile iron bend. So these are all the options, customized options as per the requirement of the project. 90-degree. Okay, so now I can also rotate the bend as per my angle, whatever angle is required. I can place it at 0 angle also. So now it is asking me specify insertion point. So as you can see, I have placed this bend here. I just need to drag and place it on the at the required point. See, so this bend has been placed. So what by standardizing these fittings, we are able to generate the BOQ automatically. Now let me show you for this pump. So this is a pump and this is a non-return valve. So let me add again a non-return valve here. ds underscore add block, and then I will go to non-return valve plan. I will go to flange, ductile iron 250, and then I will I can again give any angle, or maybe let us say I give an angle of like 211, like this. So this non-return valve has been placed. I just need to drag it and place it here. You see, so this is a standardized block which has come. I will also add show you one more block. Let me add this T for you. So this underscore add block, T is normal, flange, ductile iron. Diameter is 350, the larger diameter. The branch diameter is 250. And then let me give an angle of 301. So as you can see, this T has been added. I just need to move it to the required point, now T. So now with this functionality, you can see all these blocks like sluice valve, dismantling joint, spool piece or pipe, like this is a bend in plumb, all these, this is a reducer. So all these blocks, standardized blocks, so this is another kind of a block, are placed automatically, and then counting of these blocks becomes automatically in the list. Now we are going to see another functionality with some contours. So in our survey, we get a lot of contours, and now I'm going to show you how we can use these contours functionality. So for example, if I get these contours for any survey and I want to generate the L section profile along any path, so I can make a polyline and then I can run a command ts underscore L section contours. I have to select the polyline along which I need the profile, and then I have to select the contour layers. Then I will give the chain spacing. Then let me give a text height of 10 and vertical exaggeration is 10. Now it is asking me the point to paste the profile. So as you can see, it has copied and pasted the L section, generated the L section profile. Now this magenta color is the chainage and this blue color is the level elevation. So howsoever my profile is varying, it has generated the L section automatically and created a block for it. So this L section profile is very good, convenient for generating the L sections along any profile. So now I will also show you one more thing. We have another command called write spot elevations from contours. So we are having any contours and I have to see the elevation at any point. I will just have to select the contour and then it will show me select point. So let me select a point here on top of the contour. It will give me elevation of 27. So this contour is at an elevation of 27 meter and this contour is at an elevation of 26.99, or maybe I will just go near the contour. 27 meters, again 27 meters, the same contour is there. Let me go to another contour. So this elevation is 26.5. So this is basically a half meter contour interval of contours. So now what happens is wherever we click the point, the cursor, it calculates the relative distance from the nearest contour and interpolates the level. Like for example, this contour is 26.5 and this contour is 27. So as you can see, wherever I will click, it will, based on the interpolated distance from various contours, so it will calculate the level. As you can see, from 26.5 to 27, gradually it is increasing the level. So my level is increasing depending on the relative distance of the click point from the contours. And the further functionality of this is, once we have generated the nodes, as I had showed you earlier. So after generating the nodes, if I'm having any network, let us say I'm having this network and I have generated the nodes. So what I will do, I will isolate the layer state of nodes and contours. So my nodes and contours are isolated. I will run a command spot elevations from contours. First, I will select the text nodes, then contours, and then it will ask me for a CSV file. Let me give it a name, levels.csv. So now it is calculating the ground elevations or levels with respect to the contours set for every text, which is the junction or the node for any water supply or a sewerage network. So it will calculate the interpolated level depending on its relative distance from the nearest contours. And once again, I will say that all this programming is working very well in BricsCAD, and we are not facing any issue in the LISP programming of BricsCAD. So it is showing us a status bar that how many texts are yet to be processed. So for at every text, it is actually calculating the ground level and generating the CSV file. It will just take a while. It's done. So now this CSV file has generated levels.csv. So as we can see, for at every node, which is a junction, the interpolated level as per the contour, it has given. So for all the 386 texts or nodes, it has given us the So we can use this in any water supply, sewerage or irrigation network, any design. Now we are going to see the sewer L sections. I'm going to close this file. Now we are going to see the sewer L sections. So for any water supply or sewerage network, we have to sometimes give L sections. So we are having the LISP programming for that as well. So I will open the Excel template. Now, once we design the sewerage network in any software like SewerGems, so I have to copy the conduit table, manhole table, outfall table. I will show you, like, this is the conduit table from WaterGems. This is the manhole table again from WaterGems, SewerGems, sorry, I'm sorry. And then outfall table again from SewerGems. So we have to copy this table. We have to do some data manipulation. Some processing of this data is done in the given program template, which has been made by us. And I will just close and open the file again so that nothing is changed. And then after all these buttons are run one by one, we will just run make multiple L sections. So the backend, in the backend, a lot of VBA as well as the LISP programming is being used in generating the L sections. And again, here also we have connected Excel to BricsCAD. So now what has happened is a new file has been created in the folder, current folder, this one. So we will open this working drawing, the BricsCAD file. We will drag and drop this file in the BricsCAD and run. So as you can see, automatically the L sections are being generated, and we can see that again, there is no text overlapping here. Because whenever we generate the L sections from any standard software like WaterGems, SewerGems, or any other software, so in the L section profile as well, there is a lot of text overlapping which the drafting people has to correct the manually. So here we can see that there is no text overlapping, and automatically the L sections are being generated. So we can see that the L sections I have generated, and I will show you. Like, this is my ground profile. These are my manholes. This is my sewer pipeline. And we can see for every L section, it has given me the diameter of pipe 200 mm dia, 1:190 slope, and the material is DWC pipe. Manhole number from 1167 to 1174. These are the changes. This is the distance, depth of cut, invert level, ground level. So it has shown the complete L section. Now this is another L section from 1174 to 1085. We can see the manhole number 1174 to 1085. We can also see that the diameter has changed. And wherever there is a change in diameter, we can see there is a drop in the crown level of the pipe is same, and there is drop in the invert. So all these L section. Also, one more highlight is here is that whenever we are generating the L section through any particular pipe, if there is any pipe which is meeting perpendicular to in any manhole, so it is showing us the pipe number as well as the invert level where it is meeting. So here we can see the pipeline is meeting above the invert level. So at actual to the scale, wherever the pipe is meeting in perpendicular to this L section from any branch, it is showing. So all these L sections have been generated. We can see. Also, the plan of the network is here. We can see, as we have already generated the plan, as we have generated the water supply network drawing. Similarly, we have generated the plan wherein for every manhole we are giving the manhole number, ground level, and invert level. So this is the plan of this network, and I have generated just the L section of only the two reaches for viewing. Now another command, we are having a very beautiful command, that is ds underscore pipe viewport, wherein we are able to set these L section in the viewport. So let me select these three L sections. Now it will ask me where to place the viewports. So not only the L sections will be generated, it will also show us the corresponding plan as well. As we can see, this L section is from 1167 manhole to 1174. So the corresponding plan from 1167 manhole to 1174 automatically comes along with the L section. So the draftsman has to just place this within the sheet, wherever the sheet he has to set. Similarly, for the second L section, we can see this L section is from 1174 to 1085. So as you can see, the plan from 1174 to 1085 automatically it has generated. Similarly, for the third as well, I will just show. The L section is from 1085 to 1092. So automatically the plan from manhole 1085 to 1092 automatically comes along with the L section. So there is no hassle of finding where these manholes are lying, and there is no hassle in finding the corresponding plan for these L sections. So once we place this L section in any sheet, so there is a something called a key plan. So we have to highlight in the key plan where this reach is. So for example, I have highlighted, I will first delete this. So we are having another command ds underscore hatch rectangles. So first we will select the key plan, then we will select the plan of the L section, corresponding L section. As you can see, this hatch has come. So let me show you. Like this plan is from manhole number 1167 up to manhole number 1177. So in this as well, we can see from 1167 to 1177, the corresponding area is highlighted. Let me show you again. Select key plan, then select the L section plan. You can see this corresponding plan. As we can see, this pipeline from manhole 1092 up to manhole 1115. So this plan is from manhole 1092 up to 1115. So corresponding automatically the respective area of key plan is highlighted. Another functionality which I will show you is the KML export. So in our projects or water supply, sewerage or irrigation project, all the drawings are geo-referenced, and sometimes we have to zoom to Google Earth to see wherever our pipelines are. So we have made various commands. So I will just show you. So I'm exporting this pipeline to Google Earth. So automatically it will generate a KML file and open the Google Earth for me. So all the entire network as shown in BricsCAD now is being taken to Google Earth. Now you can see all the pipeline and all the junction, even the pipe number, the length, the diameter, even the junction data, everything has gone to Google as it is, as it was being viewed in BricsCAD. And even the pipeline diameters are again, the pipeline colors are again the diameter wise, like 63 mm diameter is almost the maroon color, and then the 75 mm is green color, and 90 mm is this blue color. You can see. So we can always anytime go to Google Earth to see where our network is. We can see if there are any obstructions or any railway crossings, national highway crossings, So if some details are not given in survey, so we can cross check. So automatically we can go to Google Earth and see where our network lies. Now we are going to see some general commands which are very useful in day-to-day use for pipe networks. This is a very large pipe network, and we can see all the pipes are connected at various junctions. So for a very large pipe network, sometimes we have to establish or we have to ascertain whether all these connectivities are proper or not, or maybe some pipeline should not be like this, or maybe should not be like this. So all the connectivities are proper or not. So we are having various commands called select upstream. So we have to select any pipeline and it will select the upstream. So this is my starting point of the network and it will select upstream. Another command is select downstream. So I have to select any pipe and it will select all the pipe network which is at the downstream of the selected pipe. And there is another command called select connected. So now since all the network is connected, it has selected all the pipes. So now let me disjoint any particular pipe from the network. Let me do that. So I've disjointed this pipe. Now I'm going to again run ds underscore select connected. So as we can see, so this branch was not selected. So automatically it means there is some problem in the connection. So if I connect this branch again, let me connect it again. And now again, I'm going to run ds underscore select connected. So automatically all the pipes will be selected again. Thank you. Now another thing is we are going to show you some very general, some more LISP commands which are very useful in day-to-day working. One is erase outside polyline. So now let me see if this is a drawing file and this is any closed polyline of any shape. I press a command called erase outside polyline, EOP. I have to just select the pipe. Automatically everything outside the polyline is erased. Only thing is that any polyline or anything, any pipeline or any polyline which is coming from inside the polyline, inside the selected polyline and going outside, that will not be deleted. Rest all the objects which are entirely lying outside the selected polyline will be deleted. You can see. So any polyline which is coming from inside the selected polyline, it will remain as it is. Now I will do undo. There is another command called erase and trim outside polyline, ETOP. So now I will again select the same polyline. So as we can see, it has trimmed all the polylines coming from inside. So so this command, all the polylines coming from inside will be trimmed. Again, I will do all undo. Now another thing I will show you is the make viewport. Now various drafting people, they face a lot of problems, and making viewports consumes a lot of time. So we are having another automatic command, make viewports. I will have to just select the entities, give a scale, whatever, like 1 in 2, and then I have to select where I have to place the viewports. So you can see the viewports have been placed, and scale of 0.5, which is 1 in 2, has automatically been given. Another very beautiful command which I want to show is we can even make a viewport along any irregular polyline. So now let me generate any irregular polyline. You can see it is highly irregular polyline and close it. So I will run a command called ds underscore poly to viewport. I will select this polyline, scale again 1 in 2, and then it will ask me for any point. You can see the viewport has come along that polyline. So automatically the clipped viewport boundary has come along that polyline. Now I will close this file and open this file again. There is another very good command called plot PDF. So now once we have actually prepared the final drawings and adjusted the drawings in layout tab in the layout. So like these are 4 sheets. Now this sheet is of and every sheet is having a separate size as well. Now this size is A1, this sheet is A1, and this sheet is again A1, and this sheet is again A1, and this sheet is again A1. So even if we can have a separate sheet size as well. Let me give this smaller sheet size as A2. So now this is a particular text which we write in all the drawing sheets. This is in a particular layer, and in this text specifies firstly is the sheet size, secondly whether the sheet is colored or monochrome, and then third is the name of the drawing, the PDF file. So I'm having a standard command called plot PDF with a shortcut PPP. So as we can see, it is generating the PDFs 1, 2, 3, 4. So in the current folder, it has automatically generated 4 PDFs. So 3 PDFs are of A1 size, as I already shown, and 1 PDF was A2 size, the sheet 2 of 4. So sheet 1 of 4, A1 color. You can see the PDF has been generated very nicely, and this sheet size is again A1. So automatically based on A1, A2, A3, the standard sheet sizes has been set in the program, and automatically the PDFs are generated. Now this is the sheet 3 of 4, again A1 size, as you can see, again colored, and sheet 2 of 4 we gave A2. So now as you can see, this sheet size has been generated on A2 size, again colored. So as we can see, a lot of list programming we have done in BricsCAD, and we are not facing any issue. And sky is the limit. All these programming we developed based on our project requirements whenever there is a requirement came, because we believe in using technology in our design engineering field. So we always try to automate whatever task is repetitive in our office. We are using multiple licenses of BricsCAD, and all this functionality is given to all our people. Their life is a lot easier because of the list functionality of BricsCAD. Lisp in BricsCAD indeed offers additional functions and capabilities beyond what's available in AutoLisp. This information is for your reference, and if you have any queries or questions, please feel free to ask in the chat box. Here are some functions that differ from those found in AutoList. They operate differently but provide additional support. This is just for your quick reference once again. From here, I would like to pass the baton over to Aman. I truly appreciate your engagement today, and I hope that sharing my journey, experience, and transition to BricsCAD has provided valuable insights to help you choose the right CAD software for you and your team. Thank you once again for your participation, and Aman, the floor is yours.
Really amazed at what Lisp can do in a CAD workflow, and certainly there's a lot to learn and execute. As a rough estimation, if the tasks you performed were to be done the manual way, it would have taken ages. Well, for the last time, let me once again tell you why is it the right time to make a switch. First of all, it's extremely compatible with the industry standard legacy DWG based CAD solutions. It's a native DWG based platform, so the files that BricsCAD uses are exactly the same, the commands and menus are all compatible, and any customizations can easily be moved to BricsCAD 2. We just saw a very good example of that. And it's very familiar, so users of that legacy product will feel instantly at home with it, requiring a minimal amount of training. It also offers a high level of license flexibility. BricsCAD products can be introduced via subscription or perpetual licensing, can be floating over a network without the need to assign each license to a specific user, saving you a lot of money and increasing your flexibility. The single design platform BricsCAD offers, as I mentioned some time ago, is unique to BricsCAD. It's invaluable where organization needs the breadth of multidisciplinary BricsCAD capability in one single environment, or just want to be able to move seamlessly between a 2D and a 3D approach. BricsCAD also features an array of intelligent AI-powered features which automate tasks, optimize drawings, and assist user input. This reduces a lot of effort, increasing your productivity, leading to fast, efficient design workflows. Again, these are unique capabilities only BricsCAD offers. Design freedom is also a mantra at Bricsys, so we ensure a high level of flexibility, which is built into our products, allowing our customers to design in exactly the way they want to. We also take an open approach with the development of BricsCAD. It features powerful API and LISP technology which enables you to easily develop your own custom apps and also gives developers a solid base onto which they can build a great solution. We have a strong ecosystem of industry-specific products which our partners have already built on our platform to address a wide range of needs. We are renowned for our high-level support, both in use of products and implementation, and are seen by our users as a highly customer-focused organization. And finally, BricsCAD is future-proof. While many established CAD products, particularly 2D, have seen very little real functional development in recent years, we continuously innovate, striving to bring you ever more productive and groundbreaking new features with every new product release. With all these unique aspects of BricsCAD, we deliver everything you need and for a very less cost, lesser than you might imagine. So hopefully today you have seen how Bricsys provides a different and unique approach to helping our customers solve design problems, be it migrating your list files from AutoCAD to BricsCAD or any other legacy CAD platform that you'd be using, or be it in terms of usability and user friendliness for your designers. To find out more, please visit us at bricsys.com and please do take advantage of our free 30-day trial to discover for yourself the BricsCAD difference. Thank you, and we are open to questions now.
All right, that's it for today. Thank you for your questions and thank you for joining us. We thank Mr. Munish Bansal for sharing an in depth look into his team's workflow using numerous Lisp routines successfully ported to BricsCAD. It's always wonderful to hear from very happy customers of BricsCAD. We hope it was useful for everyone and we'll see you again in future sessions.